Hello, welcome to my channel. In this video, we are going to be solving problem under conservation of energy, and we will see how it can be applied to solve problem under roller coaster. So the question we want to solve is given in the form of a diagram, and in the form of a statement is given below. So we have what must be the height h, that's this height, in terms of r, the radius of this loop, of a body going around this loop when the body is released from the top. So you can pause this video and see if you can solve it. Then you later come back to compare your answer with my answer. So to go about this problem, we apply the conservation of energy. And to apply the conservation of energy, we consider 2 points. These points, we call it point 1, and the next highest point when it is released from this point, which is this point here. This is the next highest point, point 2. We call it point 2, point 1. So applying the conservation of energy, the potential energy plus the kinetic energy here must be equal to this, the potential energy and the kinetic energy here too, which is giving us these points, right? So if we apply the potential energy, kinetic energy, it is giving us half of mv squared, that's the kinetic energy plus the potential energy, kinetic energy plus the potential energy at both points. So, but we'll notice that at this height, it is stationary before it is released. So the kinetic energy at this point, that's this one, will be equal to 0, right? And we'll be left with just the potential energy, which is mgh. At point 2, which is this height, the kinetic energy is not 0. The potential energy is not 0 because it is above the ground, and at this point it possesses a speed. So this equation will reduce to this. Now, this height h1 is given by this. The kinetic energy at this point is given by half of mv squared, and the potential energy at this point is given by mg 2r. This radius from here to here is r. So if here from here to here is r, we also have from here to here as r, so everything will be 2r. We have this. So we can find v in terms of these two expressions. So we have this expression here. By the time you send this one back to this point, so we have this. If you take care of your m, you have this expression. And from these points, we have our h1, we have our r, and we have our v squared. But we have asked to find h1 in terms of r, but our v squared is not known. So we have to find a way of eliminating this v squared. And to eliminate it, we apply another formula which is used for circular motion. That is the sum of all the forces acting on a particle towards the center of a body undergoing circular motion is giving us mv squared over r. So we have it as sum of forces must be equal to mv squared over r. So when the particle is at this point, it has a force acting downward which is equal to the weight. So the reaction is 0 at this point. So the only force acting on this body is the weight. And this force, which is equal to the weight, must be equal to mv squared over r. So we have mg equal to mv squared over r. At this point, we can take care of our m, and we have g equal to v squared over r. Then we can make our v squared the Sevier formula, which will be equal to gr equal to v squared. So this v squared is equal to the speed at that height in the loop. So we can replace this one with gr in that our original equation, which is equal to, remember we had gh1 minus 2gr equal to half of gr. So this half of mv squared that was here before will replace with gr. So we have this expression. So if we take this one back to this point, we have gh1 equal to half of gr plus 2gr. If we simplify this, that's 2 plus half. That gives us 5 over 2gr. We can take care of our g, and that gives us h1 equal to 5 over 2r. So this is the height that the particle will be released from for it to go round the loop, just to go round the loop, right? But in reality, we have to find H1 that must be greater than this. So we have our H1 must be greater than 5/2r, nothing less than this. If it is equal, that means the particle will get to that height and go backward. But if it is greater, then it will get to that height and move continuously around the loop. I hope this helps. Please like, share, and follow for more. Thank you.